All right, here we go. Let's talk about viruses. So, oh yeah, there's test tomorrow, so I guess that's why we're doing this. So don't forget, test is tomorrow, obviously. It's all about viruses. There's about 30 questions on viruses, and then I did throw a few, looking at the data from the CAs, because I'm that kind of teacher that looks at data from CAs. It's one of my things I just really enjoy. Anyway, I noticed that, one of the things we probably need to go back and look at was like proteins, nucleic acids, carbohydrates, lipids, all the biomolecules. So there's 5 questions, very general, but 5 questions about the biomolecules. So I know in class today I said it was 30 questions on viruses, but just again, after looking at some things, I wanted to throw a little bit of a curveball at you and put some questions about biomolecules. So it's like the first thing we covered way back in September. So look for those notes. I might look over those real quick. And it will be, like I said, just 5 questions, very general, but know what a carbohydrate does, know what proteins do, know what they're made of, the things that I told you needed to know back in September. So, all right, so on to the viruses. Looking at the test here. Basically, it's very much like your notes, except a little bit more wordy questions. So definitely know the difference in the lytic cycle and the lysogenic cycle. That is a big part of it, being able to describe the lytic cycle in different ways, being able to interpret pictures of both cycles like you've done before in class. There's a question here about if a scientist was trying to design a new medicine to help slow down viruses, what would they want the medicine to be able to do? And the answer you're probably looking for is not be able to attach to the cell at all. Because here's the thing: if the virus attaches to the cell, then we're kind of out of luck. After that, it's tough. There's not much to do once it's inside and once it's using the cell's machinery to create more viruses and burst out and all that good stuff. So if we can stop the virus from ever attaching to the cell, that would be a really, really good medicine to fight that type of virus. Speaking of viruses attaching to the cell, if there's little spiky things or little suction cup looking things sticking off of the virus, what do you think those are used for? Attaching to the cell. Perfect. Okay. Some common virus diseases. Know some common viral diseases. There's a couple questions on just, which of the following is a viral disease. There's a picture here I'm looking at of one of the infection cycles. Again, be able to recognize what it looks like when it's going lytic, what it looks like lysogenic. Your biggest clue with that is if the cell is bursting and there's little viral looking animals crawling out of it, that's the lytic cycle. If it's just showing the DNA of the cell kind of in a circle, just kind of revolving around and going in the cycle and the cell never bursts, that's lysogenic. So that's an easy way to know how that works. Why would antibiotics not work against a virus? Well, the main reason is the viruses aren't really a living thing, and antibiotics kill bacteria by screwing up their metabolism. Viruses don't have metabolism, so there's no way for a virus to really work on that. Or I'm sorry, an antibiotic to work on a virus. A lot of questions about, again, the cycles. Know that the virus, takes over the cell's machinery and makes it create new viral particles. Okay, so that's another thing there. What is HIV? What is the virus that causes AIDS? Is damaging to the body because it does what? Well, what kind of cells does it attack? Hopefully, we all know it attacks your immune cells. Remember, viruses are very, 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 very tiny. Viruses are smaller than cells. That's one of the big differences that we talked about with cells and viruses. Viruses are a smaller particle than our living cells, but they're also smaller than bacteria. Don't forget that as well. Invading the host cell enables the virus to do what? What does it have to do to get into the, or what does it do once it's in the host cell? Reproduces. What is a virus composed of? Be sure that you understand that, like we talked in class the time we went over the notes, some viruses do have a extra membrane. Okay, they have the capsid, they have the protein coat, but then some have what's called an envelope. So they have that extra membrane, and that envelope is made out of lipids. It's made out of whatever cell it's attacking. It makes an envelope out of that cell's membrane. Okay, so interesting part there, but you need to know it. Just a little bit more in depth about what a envelope does, or what it is, what it's made out of. Don't forget, so virus is a nucleic acid, either DNA or RNA. If it's RNA, remember, if the viral nucleic acid is mainly RNA, then it is what we call the retrovirus. That was in some of the review questions today, whether you were a class that did the Jeopardy or whether you were a class that was able to play Kahoot. Retroviruses are ones that, again, think about retro, going backwards, going kind of back in time. Retroviruses go backwards. They go from RNA to DNA, basically, using an enzyme called reverse transcriptase. So that's an important thing to understand. If you read an example of a virus and what it's doing to the person, be able to describe if it's in the lytic cycle or the lysogenic. And remember, if it's lytic, then that means that it would be causing harm. That's really about it. One question on retroviruses I'm looking at now. A few questions just reworded differently about what a virus, why it needs a host cell in general. So hopefully you know that. As far as the biomolecules questions, there's one on enzymes, a couple on enzymes. There's one about proteins and carbohydrates. There's one about lipids and carbohydrates and what they can be used to do. There's one about the contents of proteins versus carbohydrates. So what do they have? What do proteins have that carbohydrates don't have? So it's really about your test. I know another boring one, no kids. I don't know, they're out playing. Let's see if we can go. You want to see if we can go find one? Or a dog or something. You got to have some kind of interesting thing in the Strauch Casa. There's some dogs.